Hello everyone, welcome to Software Architecture Module 1 session. This is Ramesh Ramalingam. Let's go into the session. Okay, let's see the definition of software architecture first. So this is the definition which is given by Software Engineering Institute, and it's also published in a book called Documenting Software Architecture, Views and Beyond. This definition says software architecture is nothing but a set of structures needed to reason about a system. These structures may comprise software elements, relations, and their properties. Like this is nothing but a composition of your software elements, and it will give you a overall picture of the system which is we are going to develop. So this is nothing but a composition of software elements which are going to be part of our systems. So to be simple. Okay, now we are going to create a software architecture for a system, but like where we will start with? We'll start with our requirement or the problem which we are going to solve, and out of it we are going to get a system as the result. So before we are going and designing a software architecture for a system, it is important to understand the problem or the requirement first. So how do we understand our system? There are so many ways and practices followed in the industry, and one of the easiest way which we follow is divide and conquer. Divide and conquer is not a new thing which is used here. It's a way old technique which is used for centuries. Like it's starting from the history of it starting from 2000 BC, like where Romans were big empires. They cannot rule their country as a whole. So they have divided them into smaller nations and they rule them separately so that like it will be easy for them to manage it. So this is the same technique which we are going to follow to understand our problem. So how do we separate them? Or how do we do it? Take our problem as a whole and decompose into a smaller meaningful parts and then analyze them separately, and after you have analyzed it you can combine them, wire them up so that like we will create the analysis or the understanding of the whole problem here. So let's take an example. For example, we are going to create an application, something like a Twitter. We're just going to imagine that like we are going to recreate Twitter application. So what the user will do in Twitter, they'll come and then they will create the user account, and then they'll create the they'll put their thoughts as a tweets, and whoever following that user will be able to see those tweets and they can react on them, and then they can retweet those tweets so that like their followers can uh, see it. So this is a whole system, like to be simple, it's a simple whole system. So understanding and analyzing it as a whole system is going to be a cumbersome. So to do it, we are just separating them into 4 different smaller meaningful sections. Something like user feeds a tweet. It's a separate section here. And then a user is followed by the another user, which is another one. And then the followers should be able to see the tweets. And then the last one is like followers should be able to retweet the tweets of the person who is they are following. So now we have got smaller isolated pods, and we can analyze them separately, and then after our analysis is done, we can wire them up, and then we can see the whole picture out of it. So it will be easy for us to analyze and imagine a smaller system than imagining a bigger system. So this will help, I guess. Then to understand our system, there is another important thing, because like all our systems are created for the users. So knowing the systems in the perspective of users is most important thing before we are creating a system. And for that, user journeys are very helpful to understand the systems in the eye from the eyes of the users. User journey is nothing but a series of steps which the user will take to achieve their goal. And for example, like which is shown in this slide, something like how the user navigates through our application to achieve their goal. So what it will be our like the pathway for the user in our example. For example, in Twitter, the user has to create the account, and then they have to log in, and then they have to feed the tweet, and then they have to preview and publish it. So to draw this user journey map, what are the things we need to do? The first thing is we have to identify the users. And after we have identified the users, we have to interview the users, and we have to understand the user's requirements from the user's perspective. And then we need to draw a easiest route path for the user to achieve their goal in our application. And then we have to ensure that the route path caters all the user's needs. After we are ensuring that application caters all the needs of the user, we need to start with the best fit of our user map. So how does a user journey map looks like? Let's see the same thing here. It's a very simple illustration of a user map, which is given for our first section of the Twitter example. Something like user comes in, creates an account, and then feeds a tweet, and then preview and publish the tweet. So in the real world, it may be more complex, but like it will be very helpful for us to understand and take the best out of path out of it. This is most important when we are designing the UI part of our applications. Cool. Let's get into the next one. This is talk to Rubber Duck. So we have analyzed our problems. Now what? We have to ensure our analysis is correct, or like we have to self-evaluate the analysis which we have done. So talk to Rubber Duck, or like Rubber Duck debugging, is one of the famous technique which is used in the industry. Like for example, whatever the analysis which we are doing from our side is not evaluated if we do not have the other pair of eyes. So when the developers are working separately, it will be helpful for them to have something like a Rubber Duck. What the normal developers will do is like they would have a Rubber Duck in front of them, or like just imagine you have a Rubber Duck in like is opposite to you, and they will explain whatever they have analyzed, like the explanation which we are doing for a person. So this explanation will create will trigger the developer to understand the problem much more, and it will be creating a clear picture in their mind. And this is also the same technique which is used for debugging bugs. For example, like when we are stuck with some bugs for a long time, developers use the Rubber Duck technique to explain the bug to the duck so that like they understand it more clearly and they'll be able to debug it very easily. So we can use the same rubber duck technique to re-evaluate like or self-evaluate our analysis and ensure that it is working good. Okay, we have done our analysis and everything is in our mind, or something like we have drawn, like we have written and we have done the documentation. But like, how do we communicate, or like how do we document it for the later references? So diagrams are one of the very effective tools for documenting our analysis and designs. And also like it does communication very better than our words or like 100 pages of document does. And like creating the diagrams for an analysis and design is also another technique of self-evaluation of analysis and design, because when we are drawing it out in a separate canvas, it will be easy for us to visualize the things which we had in our mind, and it will give us more clarity on what we have analyzed and what we have designed. So when it comes to the diagrams, like UML diagrams are like more useful when you are doing the software architectures, starting from use case, sequence, year diagrams, class diagrams, object diagrams. There are a lot variety of diagrams which are available under UML, and it doesn't need to create all the diagrams for our software or the system to represent. We can choose the most appropriate diagrams for like each section. So like, because like each section and the problem which we are dealing are not going to be same. So we can choose the appropriate diagrams and we can draw them so that like it will be easy for us to remember and evaluate, and also to communicate to the others way better than the normal documents does. And to do with these diagrams, it is not necessarily to go with a like bigger tools or something like that. Just starting with pen and pencil and paper is more effective than like doing with some other tools, because like it's very rough. It can be like very quick, and you can just draw it and then erase it and then redraw it. It's very useful when it goes for like when you start with the pencil and paper, but it cannot be effectively communicated or transferred or documented, so that like we may need to use, or like we may need to document it in a better way. For that, like mostly I use draw.io, which is free and online, and which is also effective. Like it has a separate section for UML diagrams, and it does it very effectively. And you also can create a lot of other kinds of diagrams in draw.io. And then the next thing is like there are a lot of tools which are available for drawing out diagrams for the systems. Another one known tool is Microsoft's Visio. So we can use even Visio for creating out diagrams and documenting it and communicating it. When we are going for software architecture, one of the like often missed thing is non-functional requirements. It's also called as cross-functional requirements. But like, what is non-functional requirements? You may wonder like, what is non-functional requirements? We know functional requirements, right? Like functional requirements are the requirements which comes from the users or client's perspective, like what they want to achieve. But non-functional requirements are not the direct requirements, and it is not going to give any direct values to the customer or the user. But it is as important as the functional requirements, because without the non-functional requirements, functional requirements are useless. You may be wondering what are the non-functional requirements are. Just for a simple example, starting with security. Security is one of the key non-functional requirement which is used in which is required in every system. And we'll see like what are the different available non-functional requirements in the next slide. So what do we need to do? Like uh, when you start designing your system, you have to list what are the non-functional requirements which are available and related to your system, and then prioritize them. After that, you have to consider and implement in your design and like in the real implementation from the very first step. If we are thinking of like we can implement our non-functional requirements at the end of our like development, it is going to create a lot of problems for us, because like non-functional requirements are should be considered from the start of our application itself. Otherwise, like it's going to miss a lot. For example, if you're creating an application without considering the security, and at the end of your delivery, if you're considering for the security to be implemented, then it's going to be missed. Like you cannot ensure that your system will be having the best security system in place, and it's going to create a lot of redos, and then uh, like you have to scrap a lot of the work which you have done earlier to implement your security. So it's better to consider all your non-functional requirements from the zero of your system. And it is one of the factor which decides the success of our system on our application. For example, let's consider about the performance, which is another non-functional requirement. So in our same example, like Twitter, like if you're going to the application like a Twitter, and for the first page load itself, it is taking more than 10 or 20 seconds, then the user will just go out and they'll not continue to use the application. So without the performance, whatever the logics or like whatever the use cases we have developed, which are not going to be useful. So it's better to consider the non-functional requirements from the start of our application design itself and make it as an integral part of our architecture. So let's consider, let's see like what are the different non-functional requirements which are available. It's starting from security, as we have already discussed, and then availability, like whenever the user comes to our application, it should be available, and how efficient it is, how integrity, and then the reliability of our application. It should behave in the like reliable way every time. And then the usability is another important factor, scalability, because like the application needs to be scalable as easy as possible, because without the scalability, the application cannot grow. So these are very few or like very less number of non-functional requirements I have listed here. If we go into the internet, there are a lot of non-functional requirements starting from legal, and there is a lot of non-functional requirements which we need to consider for designing our application. So let's consider our non-functional requirements as an integral part of our software architecture design. Okay, let's move into the next section. Now we have analyzed our problem, and we have understood our problem, and we have known how to evolve our design or of the application. So let's consider what are the different methodologies, or like what are the different steps we need to consider for designing our application. We have analyzed our problem, and our next step is going to be designing our system, like designing an application. So now we have understood our problems, right? Like we have to implement whatever we have learned or like whatever we have analyzed, and materialize it as a system. So to start with designing our application, let's start with application types. So we need to decide what kind of application which we are going to create at first, so that like it will be easy for us to plan the things accordingly. So like based on our analysis, we need to put our considerations and user journeys, requirements, everything, and we have to decide like what kind of application we are going to create. Because like we have a lot kind of applications now are available in the industries, starting from web, mobile, IoT, desktop, and voice activated applications. Like, so what are the things which we need to consider? It should be easy and effective for the users, and it should solve the purpose of from where the original problem arised. And another one important thing is like quick turnaround time, like because like most of the time the applications are need to be delivered and tested with the real users. Otherwise, like if it is taking a lot of time to implement and getting into the market, there is a lot of possibility that this system will get outdated by the time it comes to the market. So it's better to come into the market as quick as possible, and so that like there are so many factors which we need to consider before we are selecting what kind of application which we are going to create. So how do we choose what kind of application which we are going to create? That's as we have already discussed, it is going to be decided by the requirements or the requirements of the user. So for example, if I'm like having a requirement, something like my user are going to be spreaded across the globe, and they are going to be comparatively less moving, and they are going to be having access to the any kind of internet. So maybe it's through desktop or laptop or like mobile. So in that case, it is better to use or create the web application. So when do we go for mobile application then? When we are comparing to web application, the mobile application users are more moving and they need the application every time. For example, we are creating an application, something like which helps the user to transport, so that like user cannot carry their laptop or desktop with them everywhere wherever they go. So for those kind of applications, it's better to create the mobile application so that like they can carry their mobile everywhere and it just goes with them. And the availability of the application is very high because like the mobiles are in their users' pockets always. And when it needs to reach the wider group of audience, and the audience are not very much targeted, something like internal user or like an enterprise or targeted users. So at those times, it is better to go for the mobile application when we are comparing to the web applications. So in what kind of situations we need to go for IoT applications is like whenever we need to deal with some kind of hardware, it's the only choice which we have is like to go for IoT applications, and it's better and effective, so that like it gives better user experience, like because like the conventional uh, like appliances or like the hardwares are not like very interactive. So IoT applications makes the hardware more interactive than it was earlier. And now another booming kind of application is voice activated applications. Voice activated applications are like useful when the user are not with the systems, and they just don't want to interact with the system like mobile or laptop or desktop directly, and they are in doing some other work and they want to like interact with the application. So in those kind of situations, it's better to go for voice activated applications. Something like we can make use of Alexa or other voice activated providers to create these kind of applications. It will be very helpful, and like the user is not needed to be with the systems always. They can be remote, something like they can, for example, I can just sit on my couch and then I can talk to my application, and I can ask some of the information which I want to know, or like I can instruct the application to do something. For example, I can ask the application to send a mail to a particular person about reminding something. For that, I don't need to go to the system and take it and type it. Just call the system and then instruct the application to send a mail to so and so with this subject. That's it. It just does the purpose. And then the other conventional application is type of application is desktop applications. But why do we still need desktop applications? Still, we have some like advantages of for desktop applications when we are comparing to the other kinds of applications. Consider a situation like where all the users are internal users and they are with the systems always whenever they want like access this application. Then it's better to go with the desktop applications. It can be like comparatively simpler than the other kinds of applications. And another one important thing is like as it is not exposed outside of the world or not to the internet, it is much more safer than the other kinds of applications by default itself. The attack surface for the desktop applications which are in internal network is like very less, so that like we can take advantage of it and then we can reduce the development time by a lot. So it's so important to consider our requirements before choosing what kind of application we are going to create. And nowadays, like most of the applications are created in more than one platform. Something like, for example, in the same example which we have seen earlier, something like Twitter. Twitter is available in both web and mobile applications. So we will start with one type of platform and then we will evolve it to the other types. So the growth has to be organic so that like the system will be stable and like we can go to the market as soon as possible. Cool. We have now chosen our application type. Now the next step is choosing our architecture patterns, or we can say architecture styles. So what is architectural pattern? It is nothing but a general and reusable solution which are already prepared and used for a long time to solve the common occurring problems. So these are all known solutions which can be followed to avoid some of the problems which the systems had in previous decades. So let's see in detail. So what are things we need to consider when we are choosing our architecture pattern? The first thing, do not overdo. Like people tend to choose the like most advanced or like most modern architecture pattern when what they consider as, and then they get into the problem of complex system, and it will like increase your development time and it will make your system complex, and it will be very like cumbersome for us to grow the system. So what should we do? Like start with very simple best fit pattern first, and then when the application grows we may be able to like grow our pattern also. So just grow it organically, and that will help our system to be simpler and effective. Because like implementing the complex patterns will also increase the complexity of the system, and also it will reduce the development time, and it will reduce increase the risk of failures and so on so much. So let's see what are the commonly used patterns. There are so many patterns than whatever I have given here. These are very few. Uh, and whatever I have given is like very frequently used patterns. The first one is layer pattern. Layer pattern is something like uh, in this pattern, the system is arranged by layer. For example, you must have heard about like a three-layer architecture, something like that. For example, in our application, we may be having a database layer. From the database layer, we'll be having the data access layer, which communicates with the database and fetches the data. And then above the database layer, we'll be having the business logic layer, which is communicating with the data access layer, and then doing some of the or like implementing some of the business calculations and then decision making logics. And then this business logic layer is observed by UI layer. So it's kind of like step by step stacks which are arranged. And another well-known pattern is client server. This is something like there will be a client and then there will be a server. Client will be asking for some information as requests, and server will be responding to the client. And it's one of the classic pattern which is used for a long time. And I just go into the like one of the modern patterns which we are used nowadays, that is microservices. Like microservices are most used patterns. What it does is it separates your like concerns into a smaller parts as much as possible and handles them separately. It gives a lot of freedom on scalability, and because like all pods are like separate services, so that like you can scale only whatever the pod you want to scale, and you don't need to consider about the other thing which will just sit and idle and will be used for very less time. So that also come with a lot of complexity when we are going for intercommunications, and you need to use like a lot of technologies, like I mean new technologies like RPC, or I'm sorry, RPC is a old technology, but still it is used in microservices for intercommunication between the services. And then you may need to implement service discoverability, and then like there are a lot of things which need to be done over that. So it's better to consider when we are choosing microservices whether it is worth for our application to go into the microservice pattern, because it comes with its own cost. And another one thing which is widely used nowadays is like publisher subscriber. So here uh, the system will be separated into like different smaller pods, and then one pod is communicating with the other pod by using the like events or events. For example, here publisher is the one section, system, or one of the system part, which will create the events and it will publish, and it does not care about who is going to consume those events. And then the subscribers are not going to be like consider about what publisher is doing, and they're just going to like express their interest towards just like I'm interested in this kind of information. Whenever it is available, just let me know. So whenever those kind of events are raised from the publishers, it just the subscriber just consumes it, and then they do whatever the computation they want to do. So it is more disconnected. So like when something goes down, it does not affect the others, like what it does in layer pattern or like client servers and other patterns where they are all tightly coupled. So it is better to choose our pattern wisely and then choose the best minimal fitting pattern, like minimal in the sense like the complexity of the pattern and the cost which incurs to implement it. So it's better to start with the minimum and then go about it. And also like nowadays, like we are combining the patterns based on our requirements and we are using it. It's not just one pattern which is used throughout the system. Like it is combining all these patterns and then using it whenever and wherever it is possible. So it's better to understand wherever which pattern suits and wherever we have to use it. Cool. Now we have understood what are the patterns which we need to use and how we have to use. And the next thing which we need to consider is language, because language is the core part of our application which is used for developing it. So I think you all know what a language, I mean programming language is. So I don't need to go into that part, but like I just want to give you a brief details about what types of languages are used and discussed in the industry nowadays. So it is a few in languages we can just separate them into two different categories like given here. One is based on the behavior and the next one is based on the types. Based on the behavior, we can separate the languages into object-oriented languages and functional languages. And based on types, we can segregate them into statically typed languages and dynamically typed languages. Actually, object-oriented language can be a statically or dynamically typed, and the same thing applies for functional also. So it's better to same like as we have done for architectural pattern, it is better to consider our requirements and what are the goals which we need to achieve, and based on that we have to choose our language. So let's see what is object-oriented languages are. In object-oriented languages, the main like programming paradigm is object. Like the whole language is composed of object and its relationships. So what is object? Object is nothing but an entity which we are seeing in the real world. For example, in real world, whatever we see and like what are the nouns which we can see are the objects. For example, human. Human is in like a class which has common properties and functionalities. From human, we can like instantiate a object, which is like, for example, I'm Ramesh. So I'm an object. So I have the properties like height, weight, so and so. And I have some functionalities. My functionalities are like I will eat, I can walk, I can sleep. So these are my functionalities. Kind of same like each and every nouns or like uh, whatever the entities which we can find in our requirements are identified as objects. So when do we need to choose uh, object-oriented languages? So when your problem is more related with the real world and its relationships, it revolves around the business problem and then relationships and then transactions. So it is better represented in object-oriented languages. So, and also when we are choosing the language of choice, it is more subjective and it is more on the like development teams ability and willingness to be considered, because like the ability of the development team is more important when we are choosing the language which we are going to use it for our applications to develop. So what are the different object-oriented languages which are available? Starting from Java, C++, C Sharp, and there are a lot of languages which are available here. So what is versus object-oriented languages? That is functional languages. Functional languages are not new, but like they're getting more attraction nowadays, and they're like it's having a very big history of like functional languages. So what made up or like what is the difference between object-oriented languages and functional languages? As we have seen, object-oriented languages are more comprised or like more based on objects. Here in functional languages are more based on the functions. They are composed of functions. Here in functional languages, we can see the clear separation between data and the functionality. But in object-oriented languages, data and functionalities are not different. They'll be combined into the same object. Like from a like object, for example, Ramesh is an object. Ramesh will be having the data something like height and weight, and the functionality, sleep, run, wake, all these things will be also part of the object. But here in functional languages, they are two different things. My functionalities are not nothing to do with my data. And in functional languages, there are so many concepts, and I'm just going to talk about two important concepts of functional languages. The first one is pure functions. Pure functions are nothing but a function which does not have any side effect. For example, if I'm calling a function A with parameter 1 and 2, whenever and like how many times I call the same function with same parameter, it will give me the same value and it won't affect the environment, the context. Whatever the context it remains same. So this is called pure functions. It does not give you any side effects. That means it does not change its result based on the time or complex like context. The result is just decided only based on the parameters which I pass. Okay. And another one important factor or the property of functional languages is immutability. Immutability is like the resistance to change. In functional languages, there are no variables at all. Like you cannot change the property of your data, something like. So that's what immutability is. And where my functional languages are worthy to choose. The places where we have more concurrent operations and more concurrency plays a vital role in our system. So in those kind of situations, it's better to consider functional languages, because as pure functions or the integral part of or like concept of functional languages, it gives us more security or safety on the concurrency operations. And whenever and also it's good or like it's optimal choice when your problem is not dealing much with the objects and its relationships, and it's more functionality oriented. So in those kind of situations, it's better to choose the functional language, because like it gives you more flexibility and more opportunity to use your logics very effectively and reusably. And examples of functional languages are like Haskell, Clojure, F Sharp, and there are so many like functional languages available. Okay, now let's go into the other type of languages. This is statically typed language. This kind of language types are based on the types, like how the types are defined in a particular language. For example, in statically typed languages, the type of a variable is known at the compile time itself. The compiler itself knows what kind of data can be held in a particular variable. So, what are the advantages of having the statically typed languages? It gives you less type error in the runtime, because like during the compile time or like the development time itself, you know what kind of data going to be there in a particular variable. So the IDE will be more intelligent to give you the feedback on errors like you're going to get during your compile time. And as it is the compiler itself knows what kind of data you're going to hold in your particular variable, it gives you more refined output, which gives you more performance. And those are the very few advantages of statically typed languages. And it goes well when you need more performance in your system, and then like the development time can be a little longer, because like as statically typed languages, every variable should know its type during the development time itself. It and like whenever I define some data type, custom data type, and if something changes in my requirement, it will take a lot, like some more time for me to update the same requirement change throughout my system. But so we need to consider this a little bit of extra in the development time when we are choosing the language. And for the examples for statically typed languages or like C, C++, Java, and one of the superset languages of uh, JavaScript, which is TypeScript, and so much. Okay. Opposite to statically typed languages, there is dynamically typed languages. Here, in dynamically typed languages, we do not know what kind of data going to be there in a particular variable until it hits the runtime. So, what are the advantages of having the dynamically typed languages? The first thing is like it does not have a like most of the dynamically typed languages does not have a separate compile time, so it gives you more very less running time, and then the miss of the compile time gives you very quick feedback for you. And then as it is not statically typed, it can adopt or like it is more tolerant to the changes which are happening in our requirements. And like this goes well when you have the like when you just need the optimal performance and you don't need to very much concern I don't want 99.99% of performance. At that time, like I can just go with dynamically typed languages, which is having another advantages on the development time. Like I just want to have my application to be created very quickly. Then it's better to consider the dynamically typed languages because the development turnaround time is very much lesser than when we are comparing the statically typed languages. And few examples for dynamically typed languages are like JavaScript, Python, Clojure, and so on. So when we are choosing our language, it is better to consider all these parameters, starting from your development team's like comfortness, and then your requirements, and like what kind of goal you're going to achieve, whether you're going to like require a lot of focus on the performance, or like do I need to consider my development time, uh, what the ultimate goal of the system is going to be. So it will be very helpful if we are choosing the correct language. Then though like most of the complexities have been rectified there itself. Cool. Now we have seen the different kinds of languages and what are the advantages of them and when to choose them. Now we are going to the another important part of our system, which is databases. Like this is where we are going to store all our data. So it is another important part of our system. So what are the different kinds of databases available nowadays? Like there are two different kinds of databases which are used in our systems in the industries nowadays. So the first one is like SQL based database, like RDBMS, relational database management systems, and the next one is NoSQL databases. It can also be elaborated as not only SQL databases. So what are RDBMS, like relation database management systems? In relational database management systems, normally the data are stored in the tabular format, something like rows and columns, whatever we see in like Excel sheets, something like it's same kind of format we'll be saving in the RDBMS also, but like it's a more refined, like customized way. We can create a lot of tables, and for each table we need to define the consistent schema for them. Schema is nothing but the structure of the table, or like how the table is going to look like. So here in RDBMS we need to have the fixed schema for each table, because like whenever we change the schema, there are a lot of changes has to happen as a cascading effect. And when we are considering RDBMS, they are very much used with a language called SQL, structured query language. Most of the all of the not most all of the RDBMS systems are supported by SQL, which is very commonly used language throughout the development world. And RDBMS databases are more go with transactions, more easily go with the transactions. And another one thing is like in RDBMS we can just scale it vertically. We cannot have like the same RDBMS spread it across the systems, and we cannot scale in a way like that. Okay, so what are the examples of what are the few sample examples of RDBMS? The first one is like MySQL, Oracle, Postgres, and SQL Server from Microsoft, and so on. There are so many RDBMS databases are available and widely used nowadays also. So when should I choose or the relational database management systems? Like when I know my system is going to have the defined or like fixed database table schemas, like it's not going to change as easily. It doesn't mean like I'm not going to change it ever. It means like it is very less changeable. And when we have the requirements for the system to be more relying on the transactions and the consistency of the data, it is better to consider RDBMS, which is going to be a simple solution for us. And also it's having another advantages, like which is using SQL, which is most commonly used language in the development world. So it's simple and straightforward, and it's very easy to understand when we are considering NoSQL databases. So now we have seen like when we should use SQL, sorry, RDBMS and uh, RDBMS related databases, right? And the next one is NoSQL databases. It is not only SQL databases. In RDBMS databases, we'll be storing all our data in the tabular format. It will be something like an Excel sheet. But here in NoSQL databases, it is not going to be something like that. We can still store the data in the tabular, like whatever we are storing in the RDBMS, but it can save more than that. Something like key value pair, I can just save something like a key against a value, and then I can just store my documents, graph data, and then I can configure my database to be a wide rows, where like my columns are like getting increased whenever a new data is getting added, rather than like in the same scenario in RDBMS databases. Whenever a new data is added, a row gets increased, but in wide row NoSQL databases, whenever a new data is added, a new column will be added. So there are so many use cases for them. It's better when you're going in depth and analyzing how they are really work and where in which situation it is useful. And another one bigger advantage is like in NoSQL databases are horizontally scalable, and it is easy to scalable also, and most of the times it is available as SaaS and easy services, so it is easy to plug into your application and start using it. And another one important thing which we need to consider during NoSQL databases, NoSQL database does not demand you to have a fixed schema. Still, you can configure your schemas in NoSQL databases also, but it is not mandatory. So I have the flexibility of putting anything into my database and I can take it whenever I require. But still, it has its own consequences. But like when we have requirement for like more dynamic data changes, it's better to go with NoSQL databases. And another one thing is like most of the RDBMS databases or CA based databases, something like in Captivum we have like consistency, availability, and partition tolerance. All the RDBMS databases are like consistent and available. They are CA based databases. But here in NoSQL databases, I can configure what I want to have. I can have like availability and partition tolerance, and I can have consistency and partition tolerance, and few like nowadays like modern databases, something like CockroachDBs, they support uh, the flexibility of configuring what kind of parameters I want to have in the cap theorem, and I can define my database. And the next one is like what are the like most used NoSQL databases nowadays? Like there are MongoDB, Cassandra, CouchDB, and there are a lot available nowadays. And let's see, like when we are going to choose a NoSQL database, or like when we should consider choosing NoSQL databases, the first thing is like when I do not have a fixed schema, or like when I expect to have frequent changes in my schema, it's and then I don't store no tabular formatted databases. Like I don't know, I just want to store something like graph data, or like I just want to store some raw documents and I just want to index them and then use it. Then it's better to go with NoSQL databases than considering the other formats like RDBMS. And when I need partition tolerance, as in the CAP theorem, it's better. It's only available in the NoSQL based databases. And another one thing which I consider when I'm going for NoSQL databases for my like some simpler applications also, like whenever I fetch and update and put my data back to the database as a whole, then I just go with the NoSQL databases. For example, when you're considering something like Facebook, like whenever a user logs in, it just needs to go and fetch uh, the whole information which needs to be shown in the whole page of the user dashboard or the home page. And whatever the changes which the user are doing, it just needs to update and then just put it in the database. I'm just putting it in a very simpler format. It's going to be in Facebook, it's going to be a lot complex, but like for the explanation purpose, I'm just simplifying it very much simplifying it. And then like when we're considering the scalability, comparing to RDBMS, NoSQL databases are like very less costing for scaling your applications or your database spaces, because like in your RDBMS databases, you can do the scaling only in the vertical. That means like in the single system, you need to upgrade your RAM, memory, and like your hard disk and everything to scale your RDBMS databases. But here in NoSQL databases, you can just add another one system and then you can scale it very easily. Cool. That's it about the databases and how to choose the database based on your requirements.